Video, we'll be talking about object lifetimes and ownership. We've already talked about variable lifetimes in our discussion of scopes. We know that objects are created when we declare and initialize them, and those objects are destroyed automatically when the scope for their variable ends. The problem is that objects often get passed around between multiple scopes. In fact, in the next couple of videos, we're going to see mechanisms that let us completely decouple our object lifetimes from scopes in our code. References can further complicate things by giving us variables in one scope that point to objects associated with another scope. Let's take a look at an example that shows how this can get problematic. Let's say we have code that controls multiple robots. All of our robots are controlled through the same radio. So each robot holds a reference to a radio object. This way, all of our robots can interact with the same radio. Then we have a function initializeRobots that initializes a vector of robots for us. The problem with this code shows up when the initializeRobots function returns. The question is, does the shared radio object still exist after this function is complete? The radio object was declared in the initializeRobots function scope, so it's going to be destroyed when that function scope ends. So the answer is no. Taking a reference to an object doesn't extend its lifetime, so our radio object no longer exists after initializeRobots returns. So you might be wondering, what happens to all of the references in our robot objects in this vector? Well, they are now what we call dangling references. The references themselves still exist, but the object they were all pointing to no longer does. If we try to interact with the radio through any of these references, we'll end up in the land of undefined behavior. Depending on the specifics, our program might crash or end up working with nonsense data. It will try to follow the alias set up by the reference, but there won't be a valid object on the other side. So how do we ensure that we don't end up with problems like these dangling references? One important tool is a design consideration known as ownership. Ownership is a principle that involves tracking which parts of our code are responsible for managing the lifetime of a given object. When one object owns another object, it's responsible for making sure that the object survives as long as it's needed and is then destroyed. Problems arise when there is confusion about ownership. For example, if no one ends up with ownership of an object, it might never be destroyed, and thus be leaked. We can describe the problem with our radio example in terms of ownership. The robots, holding just references to the radio, do not own the radio. They expect the radio to survive as long as they do, but they don't manage its lifetime. The owner in this case is the initializeRobots function. And the problem is that initializeRobots doesn't outlive the robots it creates. So it has to clean up the radio while the robots still exist. To solve the problem for this specific example, we could do one of two things. We could shift ownership of our radio object to something that does outlive our robots, such as the main function. We might take this radio object, move it into the main function, and pass it into initializeRobots as a parameter. Or we could leverage language features that allow for shared ownership between a collection of objects. We'll be taking a look at these features in another video. Ownership is an important thing to consider when you're designing your software. You'll often need to ask yourself questions about who should own certain objects in your code. Sometimes the answers are easy, like with local variables in a function, but other times the answers get more complicated and you have to reach for more advanced tools.